So during this video, we will discuss the technique entity relationship diagrams. And the first thing is to really understand what is data. Everybody talks about data, but what does it actually mean? So data you can look at as the raw ingredients of a recipe, for example. It's those individual facts or statistics or items of information that you might have, like numbers on a scoreboard, names in an address book, and even images on your phone. The idea or the concept of data is that it's a small item of information that doesn't necessarily have any meaning by itself. However, when you start to structure the data and you start to analyze the data, it in fact becomes what is often referred to as information, because it will then become meaningful. So data is the raw facts. Data is the raw ingredients into any information that you might create with reports or by running queries or by identifying patterns within bigger data sets. So look at data as those small pieces that makes up information. And then, of course, in turn, information is often used to make decisions. So now that you understand the basic concept, the next few concepts that you need to understand is just as important. And that is the concept of what is a database. So here you can see we've got three levels. We've got the user interface, we've got the functions, and then we've got what I refer to here as the database. Now, a normal software application like Zoom or Microsoft Word or a timesheet system you might be using at work, these software solutions all have a user interface, which is what you see on the screen, functions, which is the calculations and the logic that sits behind the scenes, and then the data, which is held within a database. Now, an entity relationship diagram that we will be discussing is sitting here. The entity relationship diagram is what you use to design the logical design of the database. So the key point here is that you are only concerned with those data elements, those facts, and that's all when you start designing a database. Now, the reason I'm highlighting this is because often people get confused with combining the database with the functions when they draw entity relationship diagrams. This is really, in fact, when they do that, when they use the functions as well as the database in the design, they are effectively using a different type of technique referred to as a class model or an object model. There's nothing wrong with those techniques, of course, but they are not the same as an ERD or an entity relationship diagram. There are a lot of similarities between these two types of diagrams. However, for the purposes of this exercise and for you to understand what entity relationship diagrams are, it's important that you just know we are only concerned with the data of the overall solution, not the functions or the user interface. Simply, how are we going to structure the data? So then there are three different types of data modeling that you can do. Firstly, the conceptual data model. So this is it's completely independent of any solution or technology and can be used to represent how the business perceives its information. And a logical data model is an abstraction of the conceptual data model, but it also incorporates some rules of normalization to formally manage the integrity of the data and its relationships. And this is where we get interested, because this is the entity relationship diagrams that we'll be discussing in the next few slides. And then just to cover off the physical data model. A physical data model, what that means is this is literally the physical exact design of how the database will be implemented by the implementation teams and the developers that knows how to design databases. So what they will do is they will use your logical model that focuses, as we say here, on a conceptual view of the data, as well as the relationships between the different parts of the diagram. And they will then go and say, okay, how can we actually physically implement this logical design? And then what the data analyst or the data architect will do is they will go and design the physical data model. So we don't actually, as business analysts, tend to get involved with the physical data model. We are mostly concerned with the logical data models. So now let's have a deeper look at what is the entity relationship diagram then. So here I am using basically an analogy by saying that the ERD is like a map of the database. So it shows how the different pieces of information, which is the entities, relate to each other. And it's very much like a roadmap that shows how different entities are connected by, or different cities are connected by highways. So it's a tool used to plan and organize data before creating a database. And it helps to make sure that all the needed information is accounted for and well organized. And just before we look at the different parts of the ERD diagram, I just also want to say that the ERD, or the logical data model that we are going to delve into, is very much a business view of the data. And as business analysts, it's our role to make sure that the business understands and gets input into how a database will be designed. Because most of the time, we are in fact modeling business data into a database for later use by that same business group. So it's really important for them to have direct input. And this is where the ERD becomes really important. So an entity relationship diagram, if you listen to the name of the diagram, it is very much about modeling entities. But what is an entity? So an example of an entity might help us to understand it really quickly. An entity is anything or person or place or artifact that we want to store information of. Like, for example, in a human resource management database, you would typically have the entity of an employee, a pay slip, a performance report, a job description, or a role. And these would all be effectively groups of data that gets managed together. So if we go back to our very initial definition of data, you will see that the employee entity is made up of these different attributes: name, date of birth, and address. Now, a data example for name would be my name, for example, Esther. That would be, in this case, an item of data. And the same goes to a pay slip can be defined by attributes like salary information. So here it might be the amount of salary, the level of salary, or however you describe pay slips, the date of the salary being paid, and the rate and the currency and so forth. So there would be all kinds of salary information attributes that you could include here. And then so on and so on. So let's look at the last one. A role entity would be described by attributes such as a role type, a department, and a line manager. Now let's look at our very first entity relationship diagram, which is, like we said before, just a logical design of all the data and the relationships between the entities. So in our previous example, we've identified that we've got an employee as an entity, a payslip, a performance report, a role, and a job description. Now, what is new in this diagram is the fact that we are starting to talk about which entities have got some kind of relationship with which other entities. So here we can say an employee definitely has a relationship with payslips, because for every one employee, they could have many different payslips in the database that we are designing. Here, we've got another example where we say the employee, every one employee could have many potential roles within our organization. You may do one job or the same role all the time, or you might change roles while you work for the particular organization. So therefore, an employee can have one to many roles while they work at an organization. And then one last example of a relationship. So the relationship between the role entity that we are storing information for and the job description is, for every role in the system, there will be one job description. So as you can see, we've got a relationship and a cardinality of 1-to-1. All right, so these are the three key elements here. We've got entities. We are showing with the line that there is some kind of relationship between some of the entities. You can see here that every entity is not connected to every other entity. So think about the logical side of things. Think about in the real world, do these entities relate to each other? And then finally, you can see the different ways that we are describing the entities that we do believe relate to each other. We also describe their relationship in terms of what's referred to as cardinality. So in this case, we are saying a one-to-many, because one employee can have one-to-many roles within the organization. And we are saying here, every role in the system can have only one job description associated with it. So I hope that is starting to make sense. So there's your entity. There's your relationships with cardinality. Now, this is another example of a logical entity relationship diagram that is shown in a slightly different way. As you can remember, when we started talking about entities, I also talked about the different attributes associated with the entity. In the previous diagram, we didn't show any attributes. However, in this diagram, we are showing some attributes as well. And this is what I would recommend that you always try and do, because ultimately, you want to be able to show what are all the different attributes associated with the entity. This will help conversations with your stakeholders, and it will also help you to define cardinality. And then, as you can see, this is a different example about a sales order. So we are showing and describing the relationship between the entities by having this diamond shape. This is optional for you to do. And they also use normal English language to describe the relationship. And this can be especially useful for using it to work it out for yourself, but also to be able to communicate what are the relationships as we understand it in normal English language. So in this case, we've got the customer is making a sales order. So we're saying one customer can make up to one-to-many sales orders. And then we are saying each sales order can only be executed by one customer. So this is really important for you to look at, because I think when you start playing with entity relationship diagrams, as I say, try and think of it logically, and try and use attributes so that you can show all the different attributes and therefore data elements that will be stored against that entity within the database. So why would we use the entity relationship diagram? So first of all, clarity. So this helps us, and when you start working on projects out there where data becomes more important, you will find that it helps you to provide a visual overview of what the database structure could be. It can also help you to identify, especially with the relationships, business rules that the business might want to introduce in terms of the relationships between data elements. Planning, this is like they say here, it's an excellent tool to help planning and designing the business database before it's actually built. And especially if you can engage your business stakeholders frequently so that they've got really good insights into what are the cardinalities and what are the rules and relationships that's being implemented. And here, once again, communication. So the ERD diagram is a great way for technical and non-technical people to bridge the gap in making sure that everybody is on the same page regarding databases. Remember to read any additional study notes that's available, look at some examples, and if there's a template available, make sure to use that.